years so they can get the benefit of a halfway decent, mediocre lesson. Okay, number 3 says radioactive. Okay, does that work? Okay, cool. And here's the one that actually, you feel good about that one? You need to get any help on that? I'll just grade that. Deal? That saves you time. I know the rest of the people are like, oh, this is bad. Oh, the humanity. Yeah, deal with it. All right, so number 3 says radioactive decay. Radioactive carbon-14 can be used to determine the age of fossils. Carbon-14 decays according to this given equation. So this looks like y equals y sub naught e to the negative point. Uh-oh. Can I see this? 1, 2, 3. 1, 2, 3. 1, 2, 3, 7. 8t. Okay, where y is the amount of carbon-14 at the time, so this is the carbon-14 at the time, t is in years, and y sub naught, this is the original amount, original and null amount of carbon-14. Okay, so how much of the original amount would be left after 3,000 years? So they want to talk about 3,000 years. So it doesn't really matter what we started with. It's going to give us a certain amount. But if you're talking 3,000 years, I'll use one of these. I'm going to go 0.1231237 times 3,000. Oh, clear. I'm going to go second e to the 0.000127 times 3,000. So this would come out to roughly that. So how much would be left? Hang on, I think I'm off. Do I not have enough zeros? 1, 2, 3, 7, 8, 3,000 years. I think I have this right. Yeah. Original. Wait, did I read that right or wrong? Carbon-14 according to the equation, where y is the amount of carbon t in years, y naught is the amount. How much the original amount would be left after 3,000 years? Okay, I can't see that anymore, so I'm going to go get the book so I can see it a little bit better. These trifocals ain't working on bad copies. Okay. Oh. I had not enough zeros in here. There's another 0 right there. That should work for us. So, second e to the negative 1, 2, 3, 4, 1, 2, 3, 7, 8 times 3,000. Calculator doesn't have enough zeros. I'll get one of these bad boys back here. Yay, there's still 8 in there. I love it when people haven't stolen them. Second e to the negative 1, 2, 3, 4, 1, 2, 3, 7, 8 times 3,000. So this is what they claim the answer is. Why would the calculator claim that's the answer? First off, is 3,000 years a long amount of time? Yeah, with respect to our lifespan, but with respect to how often things are here. So what they're talking about is, in this particular decay model, because what's taking place with this is this would do something like this. And what's going to happen is once you get out to like 3,000 years, you have gone so many decimal places of 0 that the calculator has to truncate it off. And I know the graphing calculator would take it out to 12 decimal places. And so what would you need in order to establish this to be a little bit better? Well, you could jump on Desmos with it and see if there is an intersection at that point. But the problem is you're having to go out 3,000 in the x direction. So let's see what Desmos will say. And rather than me pulling up Desmos, I'll just do it here. Desmos.com. Graphing calculator. Y equals, we'll call that 1 times e to the x. Functions, where's my e? Stats. Come on, Desmos. CDF. Length, that trade. Miscellaneous. Okay, how can Desmos not have our E button? That's no fun. Is that it? That's okay. Shift 6 of 1, 2, 3, 4. 1, 2, 3, 7, 8. X. On the wrong thing. Where's e to the x on here? Y equals e raised to that. There it goes. Negative 0.1234, 1, 2, 3, 7, 8 times, oops, times, nope, go back up there, times 3,000. Oh, that's what I did wrong. Duh. Where's it at? There it goes. And I'm going to go y equals 3,000. X equals 3,000. Sorry about that. X equals 3,000. All right, so Desmos also says that 3,000 will be down to 0. So what does carbon dating do? Do you guys know how carbon dating works? Okay.
Yeah, they take something and then they like shock all the rust off of it and then try to like
Yeah. So an isotope is basically an element that has extra particles to it. So carbon 12 is really what you have, but carbon 14 is an isotope that happens with carbon. And carbon 14 decays at a certain rate. And if you, that's the rate that they're saying, I don't know if that's a true rate or not, but what they're saying is because that isotope leaves, then if you can determine how much carbon 14 is left in a substance of carbon, it'll come back. There's actually, and it's, a lot of times they call it radiocarbon dating. There's actually a more accurate way to date when something had been. And I think this is kind of cool. So you know that the North Pole of the world, the true North Pole, is not the same thing as the magnetic north. Have you ever heard that? So the magnetic north moves, and it moves to a certain mathematical function. And what you can do is, if you come across an ancient civilizations where they had a fire, what you can do is, because when that fire takes place, the magnetic particles aimed to where the magnetic north had been, and now you know where it's at, and you can tell how long ago that fire had taken place. And what you can do is you can determine how long ago an ancient civilization had been in existence just by where the magnetic north is. So, so letter B says, hey, if you were to come across something, so after 3,000 years, this is pretty much zero. That just means that the decimal is so far out it's not there. It says a fossil has been found to have 1/100th of the original amount of carbon 14. So that's going to be, basically, you're going to multiply both sides, but in this case it's going to come out to a different number. But let's see. I want to find a better, I thought these were better problems when I first saw it. All right, number 10 and 11 we can go with. Okay, organizational growth. Because of new market opening, the number of employees in a firm is expected to increase according to the equation that's given. So this one is number 10. I'm going off the book because I can read it better. So they say that this is the equation of your employees. That's 0.3t. Okay, which means if you hadn't started your growth right yet, so today is 0. That means you basically have 1,400 employees working for your company. The reason why it's 1,400 is you plug 0 in for t, you get 0.3 times 0, which is 0. 0.5 raised to the 0 power is 1. 1 times 1,400. So what is the level of employment when the market opens? T represents the number of years after it opens. Okay, so that's what we're basing off of. So today would be 0. So that would be 1,400 raised, or times 0.5 raised to the 0.3 times 0, which is 1,400 times 1. So you have 1,400 people or employees at this particular corporation. How many employees should be working at the end of 2 years? So after 2 years, you're going to plug that in. So you're going to go 1,400, 0.5, 0.3 times 2. And we'll go with my calculator. So we're talking about 1,400 times 0.5 raised to the 0.6. So this one goes to 923.65. So about 924 employees. So why is it less than the original? Did I do that right? 0.05, 1,400. .05 raised to the 0.3 t. 1,400 raised to 0.5, or times 0.5 raised to the 0. 1,400. 1,400.5 raised to 0.6. Yeah, we're actually dropping employees. What is the expected upper limit on the employees? Graph the curve. Okay, so if you graph this curve, it's kind of looking something like this. That's your flatten the curve type of thing. So you should be having a pretty big good growth originally, and then it starts flattening out where you're still gaining employees, but it's not growing as fast is where we're getting to. I wanted this to be nicer. This is not as nice as I wanted it to be. All right, so let's open it up to other items. So let's take a look at, we're going to look at this equation. So I know that a, b to the x plus 0. So we're going to look at the trend line of the stock market. Now, the stock market is down a little bit today. Don't worry. But I'm going to look just on my phone, stocks. Do what's that? Oh boy, I hope not. So on day 6 months, 1 year. 2008? Bought more. So in 1992, which is before y'all were born, the stock market was at it was at 5,800 roughly. So then when we get to 2021, we are at 34,412. Now, this is the regression line based on it, but this is what the stock market's kind of doing. So you're not looking at the jagged curve, you're looking at the smooth line curve to show projections. And I know we talked about this the other day, saying if you had $100,000 by the time you're age 30, what it's going to become. So let's use this information based on the thing. So I'm going to call 1992 0. So how many years are we talking here? What's 2021 minus 1992? 2021 minus 1992. 23? 29? Okay. All right, so we're going to base this on 0, 5,800, and then 29 for the year 2021, 34,412. So here's a nice projection. So let's take a look at this first and find the growth rate. So this is an x, this is a y value. I'm going to take that, and I'm going to plug it in here. I'm not going to worry about the plus 0. So I'm going to get 5,800 is equal to AB raised to the 0, because that's the x. So that means b to 0 is 1. So my a value is 5,800. So now I'm going to use my a value here, plug it in here, and go y equals a, which is 5,800, b raised to the x.
This is a reminder that we do have testing the next 3 days, and teachers at the end of this period or the next period, if you do have time to take a few minutes to rearrange the desks to get them in the manner building for testing, that would greatly help. Thank you.
I'm glad we had that. All right, almost done. So now I'm going to take this here, and I'm going to plug it in, and it's going to allow me to find my b value. So I have 34,412 equals 5,000, b to the 29th. So if I divide that, 34,492, or 34,412 divided by 5,000, that's going to give me 6.8824 equals b to the 29th power. Anyone remember back from Algebra 2? How do I do b to the 29th power? What root do I have to take both sides to? 29th. So I'm going to raise each side to the 1 over 29 power. So I'm going to take my 6.834, raise it to the 1 over 29, close that. So that's going to give me 1.069. So basically, since 92 to present, the New York Stock Exchange has made roughly 7% on the money. Okay? Now, there's a rule that I haven't talked about, and I'll tell you a little bit about. This is what you want. This rule is the most important rule. It's called the rule of 72. And the rule of 72 is basically when would your money, how long would it take for your money on an investment to double? So you're going to go 72 divided by 6.9. And that comes out to, in this case, 10.4 years. So remember I said time is on your side? So if you had 10,000 double in 10 years, that's 20,000. 10,000 double in another 10 years goes up to, that 20,000 goes to 40,000. Another 10 years, it goes up to 80,000. So that's one of the things that you want to look at when we're working with this. And I'll pull up something for Friday to get this a little bit better for you to think about, where do you want to invest? And again, the main thing is the sky is falling. You brought up an interesting point. What did I do in 2008? Yeah, the money that I knew that I had in for the long haul took a dip. But here's the thing. Let's say I owned 100 shares of a company. Each of those shares is worth a certain amount of money. So let's say they were worth $10 a share originally. 2008, they dropped down to $4 a share. If I didn't sell off, I still had all the shares I originally had. They were worth less, but the nice thing is I was able to buy those new shares rather than $10 a share at $4 a share. So I bought more at $4 a share with the same amount of money I was investing. Let's say I was investing $100 every paycheck. By doing that, I was basically saying, rather than me buying 1-to-1 shares, I'm buying 2 shares for the same amount of money. And then when those shares came back in price, the shares that I bought at like $4, they're now worth $10, $11, $12. So I made the money on that. So what was the right thing to do during 2008? Well, unless you were in dire straits with money and you needed that money to bail you out of something, that's where you got hurt. Now, a lot of people said, oh my gosh, the sky is falling. I'm going to sell everything at a huge loss, but at least I still have something. But I didn't sell any of my shares. I kept buying. And when they bounced back pretty well. And where was 2008 in here? I don't know. It might have been this dip right here. I don't know. I'm just being, fictitious. But if I looked at this little thing here, it seems the sky is falling. But when you look at the overall trend, it's doing that. Were there people that lost a lot of money? Yeah. The guy who is online every day trying to day trade and make money, they're losing. Yeah.
You know what the rule of 70 is?
72. Yeah. The rule of 72, it's roughly 72. It has to do with exponential growth and why things would take place. It actually comes out to like 72.7 or something like that. But they always say rule of 72, whatever your interest rate is divided by 72, that'll be how often your money will double. Yeah. So the bigger this percent becomes, the quicker your money doubles. They got 72, they did this. It was based on this kind of model in order to generate it. Now, if you really want to know this, I can come up with why that 72 went. 72 became the good thing. What time are we out of here? 41. leaf page. Derive the rule of 72. I just want to make sure I'm going right. What is the rule of 72? The rule of 72 is a simple way to determine how long an investment will take to double given a fixed annual rate interest by dividing by 72 on the annual rate of return. Investors obtain a rough estimate of how many years it will take for the initial. Let's see, where did it come from? How was it derived? Then. What did it say?
Is it like T equals, it's like rule of 72.
Wikipedia. Let's see, rule 72. I'm just deriving the formula. Okay, I'm not seeing a derivation of it. Did you find something? Ooh. Oh, okay, that makes sense. So that's it. Hey, hold on right there. That's ln2 over ln1 plus r divided by 100. And that's raised to the, it's not raised to a power. Okay. So ln1 or ln2 divided by ln1 is doubles. There had to be more in here to give me that 72, but it's dealing with the natural log. Let me do a little more research on it, and I'll come up with why it came up. I know that it's the great thing. So if you know someone saying, "Hey, it's 10%," that means roughly every 7.2 years, money's doubling. But it also works on the opposite end when you're doing negative returns back, or mortgage rates and stuff like that. So let me look up the rule of 72, and I'll have something for you for Friday. Sound like a plan? All right. Oops. Recording.